Question number 12. A generative AI engineer is tasked to improving the RAG quality by adding its inflammatory output. Which action would be the most effective in migrating the problem of the offensive text output? So correct answer is D. And why correct? So what is the D answer? The curate upstream data properly. That include manual review before it feed into the RAG system. And now why option D is correct? I'm coming to the point. First, we need to understand what is the RAG or RAG system. RAG means retrieval augment generation, and that system retrieve the external data and feed it into the language model to generate answer. Right. If the upstream data is toxic or biased or offensive, the LLM can repeat or amplify it. Getting manual review and curation ensure only high quality or non-offensive information is indexed. So this is the most direct way to migrate the harmful output, fixing the problem at the source rather than the patching it later. And the question asked is which action is the most effective to migrating the problem offensive text out? Now option A is why incorrect? That increase the frequency of upstream data update. Update more often does not guarantee safer content. Right? You are only updating, so it's not often does guarantee you have a safe content. It could even introduce new harmful data more frequently. Info option B. Inform the user of expected RAG behavior. This manage expectation but doesn't reduce the offensive output themselves. Right. So if you are inform the user for expected RLE behavior, this this manage expectation, but means this will not reduce. Okay. And option C, restrict access to data source to a limited number of users. Here we are controlling who can access data, doesn't improve what is the data. So offensive content would be still be indexed and used. So option C is also incorrect. So correct answer is D. I explained very basic level. So I hope the answer you understand. Question number 13. A generative AI engineer is creating an LLM based application. The document for its retriever has been chunked to maximum 512 token, means 512 token each. The generative AI engineer know the cost and latency are most important than the quality of the basic application. They have a several context length level to choose from which will fulfill their need. So, question asked is document are chunked into the 512 token, 512 token each. Engineered value cost and latency cover the quality. Need no choose the cheapest and fastest viable option. So, step one is the since the document chunk is the 512 token each, the model only needs to handle the least 512 token. Right. Context length of the option D is the 512. This is exactly and sufficient. The length of the 514 option A also work, but it is unnecessarily larger than the needed. The context length of the 5024 option B and option C 32768 are the overt ill, making them more expensive and oversold. So, correct answer is If we talk about the low cost and low latency over the quality, so model size option D is the perfect. It's lightest, fastest, and cheapest. So correct answer is D. Question number 14. A generative AI engineer want their in tuned LLM in their broad data banks workspace available for the testing in their dev workspace as well. All of their workspace are unique catalog enabled and they are currently logging their model into the model registry in ML4. What is the most cost effective and secure option for generative AI engineer to accomplish their GenAI? So, an engineer has a broad data with workspace and want to model available in dev workspace. Both workspace are unique catalog enabled and model currently logged into the model registry ML4. So need to most cost effective and secure option. This is the question asked. So option A, external model registry, accessibly from all the workspace, not cost effective. So option A is incorrect. Option B, export from prod and import to dev with script. Involve duplication, extra maintenance, not more secure. Option D, duplicate training pipeline in dev. Very costly and waste of the resource. So, and option D, a log model into the unit catalog via model flow, enable read access in dev. So, unit catalog is designed for secure cross workspace sharing, and ML flow plus unit catalog integration allow model to registered once and shared across the workspace. So, this avoid the duplication, minimize the cost, and leverage existing the access model. So, correct option is the option D. Question number 15. A generative AI engineer has created a RAG application which can help to employee retrieve answer from an internal knowledge base such as the Confluence pages are the global drive. The prototype application is now working with some positive feedback from the internal company tester. Now Gen AI engineer want to formally evaluate the system performance and understand where to focus their effort to further improve the system. How should a Gen AI engineer evaluate the system? So what the question asks, a Gen AI engineer has built a RAG application and it ex- retrieve from internal KB means Confluence Google Drive. Confluence or Google Drive. So prototype work, but now want the formal evaluation to see what he want to improve, means what he can improve, what to improve. Need to evaluate both the retrieval and generation component. So option A is the benchmark multiple LLMs. This only check the which LLM is the best, but not evaluate the retrieval versus generation situation. So doesn't give us the insight on the system performance. LLM as a judge. This is only useful for the final answer quality evaluation, but does not help to diagnose the retrieval performance. So judge LLM as a judge is only used to find what the final answer quality. Okay. Cosine similarity, this is used to check the semantic similarity of the generative AI on the ground truth. But again, only it covers the answer quality, not retrieve the effectiveness. Too narrow to our formal evaluation. Okay. And the last option is the curate database plus ML flow evaluation. Right. So what it is? This is build a database to test retrieval and generation. ML flow has evaluation metrics for the both retrieval and generation component. So ML flow is best suit here because it has a matrix of the retrieval and generation so that we can evaluate from there. So this approach gives the comprehensive semantic evaluation and it helps to identify whether to improve the retrieval, generation or both. So correct answer is answer B.